Hello and welcome back to Chapter 13. Today we're going to look at Section 13.4, which is going to deal with what we call inverse trig functions. Now, up until this point in Chapter 13, we've learned how to evaluate trig functions when we have been given a specific angle. So in other words, we've said the sine of pi over 6 is equal to 1/2. And we've done that using the ratios of the lengths of the right triangles. We know that sine is y over r, or opposite over hypotenuse. Well, now, in section 13.4, what we're going to do is we're going to kind of reverse that problem, and we're going to find the angle when we're given the specific side lengths of the triangle. So what we've been used to seeing is something like the sine of pi over 6 is equal to what? And hopefully by now you know that that is 1/2. Now what we're going to look at is something more where we have sine theta is equal to 1/2, and we have to think to ourselves, what angle measure on that unit circle will give me a value of 1/2 when I go and I type in the sine of that angle? So in order to solve this, we're going to have to use what we call the inverse sine function, and we're going to take the inverse of what we're trying to find, or 1/2, and depending on what mode we're in, you should either come up with pi over 6 radians or 30 degrees. And again, this is a really good practice using those unit circle values, because this is something I would expect that you would know. Now in your textbook, and it can be found on page 792, you're given this little table here. Now for Algebra 2, all you kind of have to do is know how to use this table. When you get into pre-calc, we'll go into more detail as to why these values are going to fall where they do. But when we look at this table, if we're looking at our inverse sine function, we know that our inverse sine values that we're able to calculate, kind of more specifically with your calculator, but just in general as well, those are going to fall between a negative pi over 2 and a positive pi over 2. So when we solve for theta, this is where our solutions are going to be coming from. And that's coming when we're looking at taking the inverse sine of some, like a value, let's call that value A, it has to be between a -1 and a +1. If it goes outside of that range, then we're not able to find the inverse function, or that means that that angle doesn't exist. So if I tell you to find the inverse sine of 2, well, 2 falls outside of this range, so that's not going to exist. But if I ask you to find the inverse sine of 1/2, well, 1/2 falls in between a -1 and a +1, so then I can go ahead and calculate it, and I'll find that that angle is going to fall somewhere in this quadrant, which more specifically it's going to be at pi over 6, which we just talked about in the previous slide. Likewise, when we go to do the same thing for an inverse cosine, our values are going to fall between a 0 and 180 degrees, or 0 and pi, so the top half of our unit circle. Again, if we're typing in the inverse cosine of something that falls out of that -1 to 1 range, it will not exist, and you will get an error on your calculator. And last but not least, we have our inverse tangent. Now with inverse tangent, our values are actually going to fall between a negative pi over 2 and a positive pi over 2. And in this case, notice here that our inequality symbols are just less than symbols, to where up above they are less than or equal to for both inverse sine and inverse cosine. That's because, and again we'll go over this in more detail in pre-calc, but when you graph this, you actually have a vertical asymptote at negative pi over 2 and pi over 2, so we cannot include those values. So let's go ahead and look at example 1. Example 1 says to evaluate the expression in both radians and degrees. So when we look at part A, we're going to find the inverse cosine of the square root of 3 over 2. So in other words, if we sketch this over here off to the side, we're looking, because our cosine values are going to fall in between 0 and 180 degrees, or 0 and pi, we're going to be looking for angles up in these top 2 quadrants here. Now more specifically, when we're given a positive cosine value, remember cosine is our x coordinate of a coordinate point, we know then that we're more specifically going to be looking at this first quadrant right here. So at what radian measure can you take the cosine of, and it will give you the square root of 3 over 2. Please pause the video, think about it, try to figure it out yourself, and then hit play to find out. Okay, and the correct radian measure is going to be when theta is equal to pi over 6. If you happen to type this in on your calculator and you are in radian mode, you'll find out that the radian numbers don't work out quite as nice. In other words, you're going to end up with 0.5235. So it is a little bit more difficult to come up with a radian angles in your calculator. Now, if we think back to degrees now, when we go to take the inverse cosine of the square root of 3 over 2, you will find that the degree equivalent is going to be 30 degrees. And again, please try to use your unit circle to solve these. Now, for part B, it says that we're going to take the inverse sine of 2. Well, if you go ahead and type this in on your calculator, you should see that you end up with an error. And if you want to confirm that, okay, if you go back to that table that I showed you, I think it was on the previous slide, 2 is going to fall outside of that range from -1 to 1. So because it's larger than the range of -1 to 1, that tells us then that this angle does not exist. And because it doesn't exist, that means that that angle is undefined then. Now for our last value, we're going to look at the inverse tangent of the positive square root of 3. So if I kind of do a little sketch over here to the side, we know that with our inverse tangents, we're going to be looking at values from a negative pi over 2 all the way up to a positive pi over 2. So everything in quadrants 1 and 4. And because my tangent value is positive, that tells me more specifically that I'm going to be looking at the first quadrant alone, because I know that tangent is equal to y divided by x, and both my y and x values are positive in quadrant 1. So now I just have to figure out which radian measure. So we'll say theta is equal to. Now, hopefully by now you've got it narrowed down to the point that it's either a pi over 6 or a pi over 3 increment. And if we go ahead and think back to the unit circle, you should find that it's actually an increment of pi over 3. And to go ahead and find the degree measure, pi over 3 is equivalent to 60 degrees. Now if we want to double check our work, okay, first of all, 60 degrees does fall within that first quadrant, so that works. And if you were to take your tangent, or if you were to go ahead and type into your calculator the tangent of pi over 3, again you have to be in radian mode, that should give you the same thing as if you type in the tangent of 60 degree when you're in degree mode, which should give you the value of the square root of 3, and the value of square root of 3 as a decimal is approximately equal to 1.732. So all of these should be equivalent. Now for example 2, we're told that we have to solve the equation given that sine theta equals a -5/8, where we're going to be looking at angles between 180 degrees and 270. So again, we're going to start out with like a little sketch. And if we're looking between 180 degrees and 270, that means that we're looking at the angle that's coming down into this quadrant. So we're really looking for the angle measure that will give us, the inverse sine value that will give us a -5/8 that's going to fall in this 180 to 270. And again, 180 to 270 is going to fall right in here. Now, the issue, or it's not really an issue, but if you look back at that table on page 792, when you go and you take the inverse sine of this value, inverse sines are only good for quadrants 1 and 4. So, because I know that my sine value here is negative, which quadrant, 1 or 4, will give you a negative sine value? Now if you stop and think, sine is a y value, and my y values are negative in this quadrant here, or quadrant 4. So my equivalent inverse sine value is actually going to occur down here in this quadrant, and this is what I'm really solving for when I take that inverse sine. So to go ahead and solve this, the inverse sine of a negative 5/8, because you are given that we're between 180 degrees and 270 degrees, go ahead and put your calculator in degree mode. And when I type that in my calculator, I end up with a negative 38 point, and it's like 682, so we'll say negative 38.7 degrees. Okay, so a negative 38.7 degrees is going to be this right here. And because I wanted to know the angle between 180 and 270, that gave me that same sine value of a negative 5/8, what I'm going to do is I'm going to take my 180 degrees and I'm going to add that to 38.7. So in other words, I know that my angle has to occur down in this quadrant. That's what my request has been. It has to be between 180, which is here, and 270, which is here. So in order to find this angle that wraps all the way around, I'm going to have to take my 180 from here and add it to whatever this angle is here. Well, this angle here is the same as this, which is at 38.7. So 180 plus 38.7 is about 218.7 degrees. Now, if you want to double check this, you can go take the sine of 218.7, okay, and it should give you something around a negative 0.625, which is a negative 5/8. So you can double check your answers here. But this right here is ultimately what we are looking at for a solution. Now for example 3, it says, what is the measure of the angle theta in the right triangle that's shown? We are given a right triangle here, okay, and we're given a side length of 6 and a side length of 11. More specifically, we know that the side length of 11 is the hypotenuse, and the side length of 6 is next to that angle that's given, or that theta value, which is our adjacent. So we can go ahead and use the fact that cosine then of theta is equal to the adjacent over the hypotenuse, which in this case is equal to 6/11. And if we want to go ahead and calculate the angle theta, I can take the inverse cosine of 6/11, and when you type that in, this will give us 56.9 degrees. And if you look at your multiple choice solutions, that is solution C. And now for our final problem of the day, it says that a monster truck drives off a ramp in order to jump onto a row of cars. The ramp has a height of 8 feet and a horizontal length of 20 feet. We want to find the angle theta of the ramp. Whenever you're given a story problem, the first thing you should do is you should always draw what's been given. So we have our ramp height, we have our horizontal distance, and our vertical distance, which just so happens to create a right triangle. We're trying to find, or it tells us that we have a height of 8 feet and a horizontal length of 20 feet. And we want to know angle theta of the ramp. Well, this right here is going to be theta. So based on the ratios that were given in relationship to their angle here, I'm given an adjacent side and an opposite side. So the trig function that corresponds to an adjacent and opposite is going to be tangent. So tan theta equals opposite of 8 divided by the adjacent, which is 20. And so now if I want to go ahead and calculate theta, all I have to do then is take the inverse tangent of 8/20 or 4/5, and when you type that in your calculator, you should get something around 21.8 degrees, okay, or roughly 22 degrees. Now again, if you want to double check your answer, all you have to do is take the tangent of this 21.8 and you should get something around 8/20 or 2/5. Now it's at this point in time that we're going to conclude this video. If you have any questions, please make sure to write them down and I will be more than happy to answer them in class tomorrow. So on that note, have a good night and I'll see you in class.